welcome to Geology, Life and Healing. And this time we're going to talk about limonites. Limonites 103. So if you didn't see limonites 101, 102, so you have to see it first in order to understand what's happening in this paper. Okay, so as we saw in the earliest videos, we are talking about jarosite, goethite, and hematite. In the jarosite, yellow color or canary yellow, and goethite, dark brown, black streak, and hematite is dark red. After chalcocite, we are interested only in the superunion environment development limonites, not primary, right? So in this video, we're gonna see how other aspects of the process of the porphyry copper deposits will influence or change or modify in how we can find these limonites on the field. So the first one will be the rock type. Right, the rock type in the porphyry systems. You know, if for example in the jarosite, it's iron, potassium, sulfate, right? But you have to have a rock type that is source of the potassium. The main one is the granites, but the other source is biotite and some carbon too. They have some source of potassium, but the most important one will be granite, and there's a source of potassium. But what happens if you have, for example, limestone, right? So if you have a limestone, if you produce some acid in the system, in the supergene environment, so limestone is gonna use it, it's gonna take it first. And then probably the next one, you're gonna generate calcium carbonate, malachite, mainly, right? Before to do any other minerals, because to have chalcocite, you need to have iron sulfate or iron copper sulfate. So the rock type is going to change how it develops all your limonites in your system. So the second one is alteration. Alteration, the basic things is depending on the type of rock you have, that is going to be the type of alteration you will get. But in this supergene environment, one of the two main alteration that affects the process, the supergene process, is silicification. And the second one is argillization, because if you have silicification, one area, big area, so it's going to be more difficult to be access for the supergene water to leach out and make acid and leach, So you have big zones of silicification, little or not presence of limonites, right? So the other influence with argillic areas are argillic zones. It's sometimes, this argillic area, it looks like a stopper of the water. So change the levels of meteoric water, in the water table. So, that's how two main minerals going to change how going to deposit or develop the limonites in the superunion environment. So the third one is mineralization. So in this case, for this video, I'm using the porphyry copper model from David Lowell and Gilbert in 1969. So it's a bell shape, right? And they took the model from San Juan Kalamazoo, and so they rebuilt the model and made this bell shape. And something we see in this model, it's at the edges of the system, you have over 3 to 5% of pyrite and maybe little chalcopyrite, and at the center is the ore body for the primary mineralization, and very little of pyrite. So you have 10 chalcopyrite, one para in the center of the system, and the edges, that's what you have thin pyrite, one proportion of chalcopyrite. So if you have, the weather table, it's in the top part, is in, you have pyrite over there, so you have enough source for the sulfuric acid, so your area for the superheat environment is going to be way much better. If you are in the lower environment, when everything has been erosion, and so you have very little pyrite, so your system will develop just not much strong of secondary enrichment. Okay, so number 4, what's the number 4 that may change the process and how it develops and everything is structures. So as what are the types of structure that we have? We have the pre-ore, during ore, post-ore structures, right? Primary ore, right? But in this case, some cases there is post secondary enrichment structures too. So those are the ones that we need to looking for. One project that I know, there's a northeast structure like this, right? And primary ore, right? And there was an ore fault like this east-west, and primary ore too. And this was this post-secondary enrichment fault, and this one, it was a normal fault, right? This drop it, and drop it all the limestone. It was a Silurian age and everything. So something happened. It's you have like a bucket in here, right? So everything develops, all the supergene, everything is a bucket. You have limits in here, limits in there. You have limits. You have this area where basically it had chrysocolla and malachite, and so it's exotic copper. Little some gerosite, some hematite, but not much. So in the second one that you can, very common, you can see a drill hole is drilling. So you started your enrichment, and so your enrichment primary, right? And the second hole, drill, you go deeper and say, your enrichment it's deeper than here. What happened? So between these two holes has to have a normal fault, right? Why? Because this dropped the level of the contact for the secondary enrichment. So those are the one or two cases of the structure, how can be affected in the system. So once again, it's a resume, the rock type, alteration, mineralization, and the structure can make a different interpretation, different ways to see your limonite development and your porphyry copper system. Okay, thank you very much. I feel you like it, you enjoy it, and put a like, subscribe. Thank you.